February 1955. A 24-wheel diesel-electric beast rolls out of Longview, Texas, built to haul massive cargo across roadless Arctic snow for the Cold War's DEW line. The LeTourneau VC-22 snow freighter was a cold-weather giant with no equal. Its story would end in fire. To construct this massive chain of remote radar stations, builders faced a daunting logistical challenge, delivering hundreds of tons of heavy equipment across trackless tundra. Seasonal ice roads and cargo planes were expensive and unpredictable. Seeking an alternative, Alaska Freight Lines commissioned RG LeTourneau Incorporated to build a land train capable of carrying 150 tons through heavy snow. While records differ on whether General Electric or Western Electric held the primary defense contract, the commercial agreement was clear. Alaska Freight Lines paid a $75,000 advance on a $450,000 contract. At the factory in Texas, workers assembled the massive machine in record time. The vehicle was completed on February 17th and shipped north on March 16th, transitioning from a warm factory floor to its grueling Arctic assignment. The machine shipped north was a structural colossus. At its head stood a towering locomotive command unit, pulling 5 trailing cargo cars linked together to function as one integrated freight system. This steel caravan, engineered by LeTourneau, stretched to an overall length of 274 feet. On the open snow, it looked less like a road vehicle and more like a mainline train running trackless across the tundra. Each of the 5 cargo trailers measured 40 feet long and 16 feet wide, providing a broad, stable platform built to survive extreme conditions. A single car could carry 30 tons of fuel, steel, or heavy machinery. Together, they gave the snow freighter a rated payload capacity of 150 tons. This colossal physical footprint established the structural baseline for a machine destined to haul heavy freight across the pathless Arctic, setting up an engineering challenge that would push mid-century drive systems to their absolute limits. To move a 274-foot caravan across the trackless tundra, LeTourneau discarded conventional mechanical drivetrains. A vehicle of this size, running on standard mechanical axles and drive shafts, would have snapped its linkages at the first steep ridge. Instead, the engineers turned to a distributed diesel-electric system. At the heart of the lead locomotive sat 2 massive Cummins NHV 12BIV 12 diesel engines, each generating 400 horsepower. But these high-output diesels did not connect directly to the wheels. Instead, they spun massive generators, converting diesel power directly into high-voltage electrical current. This electricity traveled through heavy-duty cables along the entire length of the train, feeding 24 independent, hub-mounted electric motors. One motor sat inside each and every wheel hub, from the front cab to the very last trailer. This gave the snow freighter a true 24-wheel drive arrangement, ensuring maximum contact with the frozen ground. By placing the motors directly inside the wheel hubs, LeTourneau eliminated the need for heavy drive shafts, fragile differentials, and complex physical linkages between the separate cargo cars. U.S. Patent number 2,726,726, titled Electric Vehicle Wheel, outlines this very concept, detailing how a wheel-integrated motor and planetary gears could provide self-contained propulsion. While the patent itself shows the conceptual blueprint rather than the exact layout of the finished snow freighter, it reveals the engineering gamble behind this massive land train. As for steering this behemoth, early reports claimed a mechanical rack and pinion system was responsible, but the exact mechanism remains unverified in official company documentation. Controlling 24 independent motorized wheels on uneven terrain was a massive engineering gamble, with every single wheel relying on a continuous flow of electricity to keep the giant moving forward through the deep snow. To grip the frozen wilderness, the snow freighter relied on 24 massive tires, each measuring 88 inches in diameter and 38 inches wide. These giant low-pressure tires spread the vehicle's immense weight over a wide footprint, preventing the train from sinking into soft snow while maximizing traction. LeTourneau advertised an operating capability down to -68 degrees Fahrenheit, though this was a contract specification rather than an independently proven performance. In these extreme conditions, the cold threatened to freeze fuel systems, gelify lubricants, harden rubber seals, drain batteries, and snap brittle wiring. While exact details like tire ply count, compound, and specific cold start aids remain unverified. The physical battle to keep this machine alive in the deep freeze was constant. Because of their shared electric wheel tech and signature yellow paint, people often mistake the snow freighter for the broader LeTourneau overland train family. But they are separate machines. While the snow freighter was a private cargo hauler built for Arctic ice, the overland train was a family of 6 models designed with heavy military backing for global off-road use. The snow freighter ran on 24 wheels, but the massive, later TC-497 version of the overland train featured 54 wheels and stretched a staggering 572 feet. These military machines swapped early diesel setups for gas turbines, hauling up to 200 tons across deserts and tundra alike. While promotional films painted a picture of effortless Arctic travel, independent data on the snow freighter's actual speed, fuel burn, and maintenance hours remains virtually non-existent. The reality of keeping a 274-foot steel caravan running in the deep freeze was a logistical nightmare. Every journey required hauling heavy replacement parts, giant spare tires, and specialized electrical tools across trackless wilderness. Moving the massive vehicle from the Texas factory to the Alaskan starting line had already racked up immense shipping costs. Once on the tundra, operators faced the physical limits of the machine's extreme length. Turning or reversing on narrow, bulldozed trails became high-stakes operations. While 24 independent drive wheels provided theoretical traction, they also multiplied the potential points of mechanical failure. If just one critical electrical link failed, the entire freight system risked grinding to a halt. In early 1956, during its third scheduled run, those theoretical risks became a hard reality. While descending a steep grade near Eagle, Alaska, the massive train jackknifed. The sudden misalignment strained the propulsion system, and a fire erupted in the locomotive's power generation compartment. The blaze gutted the control car's electrical drive systems, ending the vehicle's working life. No public incident report survives, but legal records from the time link the fire directly to the end of the freight contract. Today, the gutted locomotive and trailing cars sit rusting in the brush near Fox, Alaska. Without official decommissioning papers or scrap receipts, the giant remains exactly where the Arctic wilderness claimed it. Today, the decaying Titan remains frozen in time. It stands as a monument to an era of raw, untamed ambition, proving that sometimes the boldest dreams leave the deepest tracks. Subscribe for more lost history.